Hello viewers, welcome to MAGESH Chemistry classes. In this presentation, we will discuss CSR-NET, TNSET, TRB Assistant Professors, Physical Chemistry Topic 1. In this area, we have the syllabus, Basic Principles of Quantum Mechanics, Postulates, Operator Algebra, Exactly Solvable Systems, Particle in a Box, Harmonic Oscillator, and hydrogen atom problems, including shapes of atomic orbitals, orbital and spin angular momenta, finally tunneling. This presentation consists of operator algebra, what are the properties of operators, and the important operator commutator, properties of commutator, and all the things problems, MCQs will be discussed. Move on to the topic. Operators algebra. It starts with the function. What is function? Function is a rule that relates two or more variables. For example, we can say the z is equal to x squared y. Now the z is the function of x and y. So function is a rule that relates two or more variables. The two variables are here, x and y. Okay. Then what is operators? Operators operates on a function and generate a new function or a constant entity. A single operator operates on a particular function. What is function? Function is a rule that relates two or more variables and generate a new function or a constant entity. Now see the function x squared, the operator d by dx. This is equal to 2x. A simple mathematical operation. Here it is the operator. This is the function. This is the new function. Clear? The operator operates on a particular function to form the new function. Okay. Consider this example. D by dx, x is equal to 1. What is the operator here? The operator is this one. And this is the function. It produces the one constant. So operator operates on a function and generates a new function or a constant entity. Operators are generally denoted by the cap letter, and operator without function is useless. Now come to the characters of the operators. This video fully covered the operators part and properties of the operator, and one of the important operations, that's a commutation, is going to be discussed. Now the characters of operators. The first one is the operators are directional in nature. Let us consider this operation, that is d by dx x cube. What is that value? The value is 3x squared. Some of the simple operation you have to know. That is a formula, differentiation formula, d by dx x power n is equal to n into x n minus 1. By this way, the value is 3x squared. Generally, operators operates from the left side of the function. Operators operates on the left side of the function from the reverse side. See this operation, operators, this is the operator and this is the function. Operator operates the left side of the function. Here the d by dx operates left side of the function x cube. Suppose it is operated in this side, right hand side, that is dx cube dx. This is not equal to 3x squared. Okay. So operators are directional in nature. In particular direction only it operates. What is the direction? The left side of the function from the reverse side. The next property, nth power of the operator means operator is operated n times. The operator is the n power, that is power 2. It is the function. This is equal to clear? Nth power of the operator means operators is operated n times. Here the power is 2, so it is operated 2 times. Clear? One more example. Dx x operator square. This is the function. This is equal to, this will be operated by 2 times. So d by dx operation x. Okay. Function of x. Okay. So 2 times the operation is carried out on the function f of x. Simply it is not equal to, it is similar to the algebraic expression a plus b whole square. This is not equal to d by dx whole square plus 2 d by dx x. So this is wrong. Okay. The nth power operator means operator is operated n times. Okay. So this is second quadrant. Now the third property, to every observable in classical mechanics, there is a corresponding operator in quantum mechanics. So in quantum mechanics, for any classical parameter, you have the operator. The first one is the position. Position, it is x, y, z, 3-dimensional. The operator is said to be x cap, y, and z. What is the operation here? It is multiplication. Yeah. Then momentum operator. Observable quantity is momentum. So the px, py, pz. The operator px, this is equal to minus I h cut d by dx. So what is the operation here? It is a differentiation. Okay. So in case of py, what is the value? Minus I h cut d by dy. Pz is equal to minus I h cut d by dz. So the operation is differentiation with respect to x or the y or z, and the factor multiplication. Multiply by the factor minus I h cut. The value of h cut here is given as h cut is equal to h by 2. One more example. The operator in the x direction is given as minus I h cut and differentiation d by dx. This is also equal to minus I divided by I, dividing and multiplication by the term I, into h cut d by dx. What is the value? It is I square by I into h cut d by dx. The complex conjugative, that is I square, is equal to 1. So this is I square is equal to minus 1. So it is 1 by I h cut d by dx. This is equal to h cut by I d by dx. So in this term, differentiation with respect to x and multiply by the term I minus I into h cut or h cut by I. So this is also the another term. By expanding, what you write, R is equal to h by 2 pi I, because h cut is equal to h by 2 pi. So these are about the momentum operators. So it is observable and it is also connected to the operator and some of the process. So to every observable in classical mechanics, there corresponds an operator in quantum mechanics. So this is another properties of the operator. In case of kinetic energy, so it is kx, ky, kz. The corresponding operator kx is equal to minus h cut square divided by 2m into d squared by dx squared. So what is the operation? It is double differentiation. And multiplied with what's the term? Minus h cut square divided by 2. So in this way we can write ky, kz, etc. And the potential energy operator. Potential energy is the term. So different direction Vx, Vy, Vz. The operator is Vx, Vy, Vz. The operation is multiplication. So regarding third property, we can say for every observable in classical mechanics, there corresponds an operator in quantum mechanics. Clear? Find the value of the momentum operator Px x cube. What is the value? Here, the momentum operator Px, we know that it is minus I into h cut d by dx. It is a momentum operator on the function x cube. Okay. So this is equal to minus I h cut into exponential power, it is 3x n minus 1. So it is 3x squared. Find the value of this is minus I h cut 3x squared. This is equal to minus 3I. Our answer is clear. Next one, find the value of a square, that is the operator power 2. That means it is operated by 2 times. So it is a property of the second one. Operating on an arbitrary function f of x. What's the meaning of that? It is a power 2. A power 2. So this is nothing. This x plus d by dx. Operator x plus d by dx function of x. Correct? So this is the meaning. So this is equal to x plus d by dx and x operated on x power x plus d dx. So the operation is on the left hand side of the function. So this is the second one. So this is equal to x plus d by x. Okay. This is x operated on f of x plus df of x by dx. Clear? So this is equal to x operator square f of x operated on this and x df of x by dx plus f of x dx by dx. So this will be 1 plus x into f of x by dx plus d square f of x by dx square. Okay. Then there are 2x d of x, so it will be 2 times. So you can write, I am going to write here, s squared f of x plus 2x d f of x by dx plus d squared, that is f of x1 or f of x1, plus d squared f of x by dx squared. So multiplying by the term f of x, what you get? This is equal to x square plus 1 f of x clear. So 2 x d by dx plus 1 value 1 plus d square by dx square. So this is the end. Okay. So find the value of a square. X plus dx is equal to this one. Next one, total energy operator. Total energy operator is nothing. It is the sum of the kinetic energy and the potential energy. So it is said to be Hamiltonian operator. That is H is equal to. What is the kinetic energy operator? It is the second order differentiation and the multiplication with the term minus h squared by 2m d squared by dx squared plus potential energy in the x direction Vs. Similarly, Hy, Hz you can write. The total energy H is equal to Hx plus Hy plus Hz. So H total is equal to H is equal to Vy plus Vz. This will be h squared by 2m and this del square plus b. So this is said to be Hamiltonian operator, total energy operator, and this is the Laplacian operator. Okay, so it is about the total energy operator. Then our fourth property, operator must be linear in quantum mechanics. This operator is a function of f plus g. This is equal to the left hand side, the function of f, and the another function g. So one more example, it is d by dx 4x cube. So there are two functions. So it is up. Quantum mechanics operator linear in property. So you can write first d by dx and the differentiation of 4x cube will be 3x cube plus 1x cube. So this is equal to 3 into 3x square plus 3x square, totally 9x square plus 3x square, it is equal to 12x square. Suppose it is directly differentiated, what do you get? D by dx 4x cube is equal to, first one is a constant, that is 4 into 3x square. This is also a 12x square. So what is the conclusion now? Differential operator is linear. Suppose you consider the square of this 7. The 7 squared is equal to 4 squared plus 3 squared. So it is not equal. So square is not a linear function. Then operator should not apply to the constant value also. For in this case, it is not applicable in the constant value. The next one is a commutator. Commutator is a mathematical operation in which we interchange the position of the operator. Say here on operator, we interchange the position operator. After interchanging the position, the value remains same. So after the interchanging, also the value is the same. Then it is said to be commutator. So here the operator are interchanging the position A then B, here B then A. Both are equal. Otherwise, AB minus BA is equal to 0. So if AB is equal to 0 or AB minus B is equal to then 0, the operator A and B are said to be commutator. Next one, find the value of commutator x and dt by x. The wave function is chosen for the computation. It is equal to the operator x d by dx. What is commutation? The position of the operator is changed. So x, the position is interchanged. If the position is interchanged, the value is same, then it is said to be commutator. We are going to verify the values are same or not. So this is equal to 0 if it is commutator. So this is equal to x, and it is operated on this one by dx minus d dx operate. This x is operated on this one. So x into x. Okay. X is the linear operator, multiplication operator. So this is equal to x d x by dx minus, it is a differential operator. Okay. So first differentiate to the x, then with psi x. So x d psi x by dx minus psi x dx by dx. So this will be 1. So this is equal to x into d psi x dx x. So this will be 0. So the final answer is psi x. Okay. So this is equal to minus 1. So these two operators commutating or not. So it is equal to minus 1. It should be 0. So the value we get is minus 1. So this is not commutator. So commutator means the position of the operator is interchanged, the value will be same. The next one, the operation of commutator x power 4 d by dx on f of x. X by d of x, the function of x, this is equal to minus 1. So we have already solved. Then it is square d by dx on function of x, this will be minus 2 to x. Okay. And the x cube d by dx function of x equal to minus 3x. We can say x power n d by dx, the operator, is equal to n into x n minus 1. Okay. See the power x power 4 d by dx. So this is equal to minus, and the power is equal to 4 x n minus 1. So this is the answer. Then the properties of commutator. The first property is anti-symmetric. In order to understand this anti-symmetric property, let us consider this example, the graphical representation. There are two types of graphs. So it is origin. So it is plus x and here minus x. So it is origin. Consider this wave function. Consider this type of wave function also. So this is origin. 0. Here plus x and it is minus x. Here this wave function on the x is equal to the wave function on the minus x. Okay. It is said to be symmetric. In this direction, the wave function psi x is equal to minus psi x. And this also minus. Clear? So this is equal to minus psi x. Here the x value only changes. So it is symmetric and it is called antisymmetric. So commutators are antisymmetric in nature. So this is the first property. In case of commutator, what do you write? Now the A operator B, this is equal to minus of A. So this is the concept. Okay. In case of commutator, A dot B is equal to minus, so it is antisymmetric. Now the A dot B is equal to AB and BA. Okay, this is equal. So this is equal to minus of BA minus AB. Correct? So this is equal to minus B dot A. Clear? By using this relation, you can find the value of this one. The momentum operator Px into x power n. So the two operators. It is antisymmetric in nature. So this is equal to minus x into x power n. How can you prove? So momentum operator is Px is minus h cut into I and d by dx into x power n. So this is equal to minus I h cut. The differentiation of this one is n into x n minus 1. Okay. The x power n px. Now the position is reversed. What do you get? It will be plus n x n minus 1. Here one relation. Momentum operator x is in the power on this direction, and the direction is reversed, the sign also reversed. Here minus and it is plus. So you can write that the commutating operators are antisymmetric in nature. Okay. Using this relation, one problem is discussed. The value of commutator x3 is equal to, simply say it is equal to minus of x power 3 px. Clear? So what is the value of this commutator? So it will be plus or minus. So x power 3 p power x. See, the value is plus. And px, x power 3, the value is minus. So it is a simple transition. As the x cube p of x operator, this is equal to, it will be plus the values. So it is plus I into h cut, and the power is 3. So it is 3x square. So this is your answer. Momentum operator px is equal to minus I h cut 3x square. So in this area, you have to recall something. That is x power n p power px operator. This is equal to plus h cut n into x n minus 1. Suppose it is reversed. Px x power n will be minus h cut n x power n minus 1. Then the commutator operator are linearity in character. That is a, b plus c. So this is operator a and b. This is equal to, you can write AB and AC plus DC. AB, AC. So the two operator A plus B, so it is A plus B operator, and C plus D is another operator. So this is equal to, in linear character, so A is with the C plus A with the D, then plus B with the C plus D with the D. So this property is linearity in nature. The next one is the distributivity. So it is an important character of the into BC. So this is equal to AB C plus B into AC. Okay. So right to left. So see this, C is taken out, AB, and center B is taken out to AC. AB C. This is equal to A B C plus AC B. So this function is the distributive function. One more problem here. What is the value of x into px square? How can you find out? right? It is equal to x into px into px. So writing distributive function, what is that? The first is x into px, it is a into b, and c is in the out, plus b is in the out, the x into px. X dot b is equal to I into h cut px. Get the px into I into h cut. So this is equal to 2I h cut px. Okay, this is the value. The value of then x px cube. By applying this distributive function, you get the value 3I h cut px. In this area, we have to summarize some of the important thing, that is x into px power n. X n p power x. So x is in the power. So x into p power xn is equal to, what is the value? That is n I into h cut px n minus 1. So here px square. Okay. Then xn power px is equal to I into h cut nx n minus 1. So x in the power, the value is like this. Px in the power, you got to apply px. Then px into x power n. Okay. So this is equal to minus I h cut nx n minus 1. Px power n x is equal to minus n I h cut n px n minus 1. Next one, operator commute with itself and with its power. Operator commute with itself. So any operator commute with itself. So a is equal to 0. Otherwise d by dx, this is commute and is equal to 0. So the operator commute itself, it is 0. Then our fifth property, linear operator always commute with the constant entity. Linear operator always commute with the constant entity. The operator with the linear function is equal to 0. This is equal to a is equal to, the position is interchanged. Okay. So this is equal to ay minus ay. So this is equal to c. Then sixth one, if both operators have the multiplication as operation, then they are commute. The operator have the multiplication operation. What are the multiplication operation? That is x si is equal to xy psi minus yx psi. This is equal to 0. Let us consider two multiplication operator. That is, one is a position operator and the potential operator. Potential and the operator both are in the multiplication operation. Then is equal to 0 because both are having the multiplication operation. So the operator has the multiplication as operation. They have commute to each other. Okay, viewers. This is the end of our presentation. Once again, we are going to summarize all the things. First of all, what is function and what is operator? Function is a rule that relates two or more variables. Operator is a function and generate the new function or a constant entity. It is operator, it is a function. New function is a constant. Character of the operator. Characters of operators. Operators are direct in nature. Nth power of operator means operator is operated n times. Any observable in classical mechanics, they correspond to the quantum mechanics. The operation we have seen. And some of the problems we have discussed. Thank you for watching this video.